Hey guys, MillBox Expert Mike here, and today I'm going to show you everything you need to know to be successful when it comes to milling crown and bridge cases with MillBox. Let's go. All right, so we're going to go ahead and start by opening up MillBox and clicking on New Job in the top right-hand corner. In doing so, I'm going to select the machine and the material that I'm going to utilize for milling. Now, MillBox will track the workflow as we're going throughout the process, so we can see that this bar will actually progress as we further ourselves along in the workflow. And once I've selected my machine, my material, and I've selected my fixture that I'm going to be using for this job, I'm going to hit the checkbox to move forward. Now, one little caveat that some of you guys may have, depending on your version of MillBox, you may have different tool profiles. And this is very important because if your tools are different from what the manufacturer has specified, or let's say that you're utilizing a different set of tools like carbide versus diamond or long versus short tools, you need to make sure that you make the proper tool selection here within the tool profile that's available. Now again, that's under the machine, under the new job. Now I've made all my selections, so I'm going to go ahead and move forward by clicking on the checkbox to proceed. MillBox is automatically going to take me to the import STL step. So this is where I'm going to import my files into the job for milling. I'm just taking a quick look at my files here just to make sure that the orientation is correct here in the preview. If it's not correct, I can actually either click this preview to get a better view of that file. Maybe if I need to do some QA here, I can see some general height information. But we actually have this really cool tool called FileHub. And utilizing FileHub, for older MillBox users, you may actually have this utility called Lab3D Explorer. It's more or less received a facelift in recent months. And what we're going to do here is simply analyze our files to make sure that the occlusion is facing up and that the prep is facing down. Now in this particular case, all of those previews look good. Now in the instance that this was flipped, let's say that the preview showed upside down like this would be a problem that I'd want to correct before I import it into the CAM. The orientation of your files are very important to the CAM software. So this is directly impacted by the way you output your files from the CAD. If you notice that your STL files are coming in flipped sometimes or all the time, you may want to contact your reseller so that way they can get into the CAD settings to correct that output problem. All right, so once we've verified that our file is good to go, we can simply click on the X to get back to MillBox and import this file. So I'm going to start by importing my largest file first. The reason I do that is MillBox takes a little bit of time to detect the features of this particular part. So as that's being detected, I can utilize that time to now navigate to and import my other crown that I'm going to be pulling in. Now I'm going to be pulling in a bridge and a single crown for this particular example. So we're going to make sure that the curves and surfaces were detected properly, and then we're going to get straight into nesting. So now that I've imported my STL files, I'm going to go to the stock selection, and we're going to choose what disk we want to utilize based off the minimum thickness required. So this is going to look at the tallest part that I've imported, and in this case I need at least a 16mm disk, so I can see I have 2 available there. Now MillBox is going to look for the disk that's most appropriate where all of these files could fit. So if this disk, for example, was 98% utilized, it may decide to go down to the next disk in the list and search through those. So MillBox always encourages you to use the disks that are most used first, so you can kind of get those out of your stock library. And this is what it looks like essentially when I've imported a partially used disk. We can see all those milled spaces that were cut out from before. Now, if we wanted to create a new disk, we could also do that. I'll go back in that step to the stock selection. And instead of selecting from the number of used disks, I'm going to hit on this plus symbol so I can go ahead and create a new one here. We're going to put in our shrinkage factor. And this you're going to find on the collar of the disk. We're going to give this a name. I'm just going to call it test ZR. And then we're going to give this a lot code just for tracking, for traceability. And if you did have a barcode printer and scanner, you could actually print out a barcode and affix this to the collar of the disk. And if you have the barcode reader, you can actually scan that to import partially used disks. So you don't have to hunt in your partially used stock library. You can simply just hold that disk up to the computer, scan it, and it will actually automatically import that file for you. So next I'm going to nest all of these elements. I'm going to say yes, I'll let it auto nest those. All right, and now it's placed this here. So we're kind of at our final step, which is to calculate the toolpath. But before I do that, I'm just going to do a quick check. I'm going to flip this disc upside down so I can have a better view at the bottom, and I'm particularly looking for the margin lines. For crown and bridge cases, these are going to be some of your most important features that you're going to want to look for, and that you're going to want to make sure is not only present but accurate to the actual margin itself. So if this red line was kind of bouncing back and forth off and on the margin, then we certainly would want to go in and make that adjustment. Or if the margin line wasn't present at all, this pink arrow would actually go away. This is actually our insertion direction. So if we click that, you can see it changes the view so we can actually see that path of draw. But let's simulate what happens if the margin line just doesn't get imported. So I'm going to go in and delete that margin, and we're going to go in and redetect it. So under Tools, Curves and Surfaces, you're going to see Margin Line. And for Margin Line, we're going to click on Detect Cavity. Now, when I click on Detect Cavity, we can see that the margin line thickness comes up. We're going to set that appropriately, and then simply click on the internal prep wall, and hopefully we get a good margin designation. Now, sometimes this doesn't always give us the cleanest line, or it doesn't always line up along the inner wall of that margin. And if that's the case, we're going to actually probably want to use our manual designation. So we don't necessarily have to delete the margin if we want to just replace it. You can actually use this manual marking tool. I'm just using my 3D mouse here to kind of rotate my view around as I'm clicking and placing points, and it'll lock in each of those points. Now, if you commit a mistake, like you do something like this on accident, no worries, we'll come back and fix that. But basically, we want to hug this margin line as closely as possible until we get all the way around to the other side. So you can see we've closed that loop. And over here in this area that we want to go in and correct, we're just going to get back over there, and there's two options. I can drag and drop the existing control point here, or I can actually create additional control points. You can see when I click here, I'm creating additional areas that I can now drag around and really customize exactly where I want that margin line to be designated. So typically you only have to do that on cases where either the margin's really broken up, like in the case you might have a really bad scan, or the design wasn't 100% ideal. But this is effectively what we're expecting to see. We want to see this inner margin line, most important, to show up here. And this outer margin line that gets projected, we want it on the actual margin line itself, or slightly in like this. This is a good result. I wouldn't want this, for example, to be way out here in open space. Otherwise, we could end up with some minor undercuts that get left behind and unmachined at the base of the restoration. So we're just going to perform a quick visual check on the rest of the bridge here, and everything else looks good on the bridge. And effectively, the process for designating a margin on a bridge versus a single unit, exactly the same. There's no differences whatsoever. So the only other things I'm going to do for this particular case is just check the placement of my support pins, get those approximately where I want those to be, and then I'm going to send this to nesting. So I'm going to start by looking at this single unit. Now, this support pin's on my facial surface, so I probably want to get rid of that so I don't have to do extra finishing. I think I could probably get away with just putting 2 support pins on the back of this crown. All right, so we can see from a nesting perspective, we've reduced the amount of time it's going to take to machine this, because now that tool can move unrestricted along the facial surface, so we'll actually speed up that milling time. Less supports are better when you can. More supports, definitely not better. It's going to cause more milling time and things like that. When you're thinking about supports, there's no real right answer to how many you need, but you certainly don't want too many and you don't want too little. And so depending on the material and your experience nesting, you may want to consider experimenting around to find out what works best for you in your lab and your material. All right, so now I'm going to go ahead and move my support pins around on my bridge, kind of get those exactly where I need them. Now my fixture is kind of in my way here, so what I'm going to go ahead and do is do Control E on my keyboard. It's a keyboard shortcut to get rid of the fixture. And in doing so, I can probably get rid of some of these facial supports. I'm going to leave some of the others. I'm going to move my support pins closer to the corners of the restoration, so I'm staying off of the facial, getting closer to the interproximal, but not necessarily getting in that area, that sensitive design space. And just moving my support pins closer to that equator line if I can. Now, one thing you can do if your equator line's really close to your margin, you could end up with like chipped out margins or just like kind of messy where the radius of the tool can't fit in here. So one thing you could do to kind of minimize that, if you have enough space within the disk, and this is going to be close because this is right at 16, you could maybe rotate this part back a little bit to make that a little bit less less aggressive or not as low on the margin. But since I'm restricted to my nesting space, I'm going to try to work with what I have, and I'm going to use a different type of connector. Instead of my cylindrical connector, you can see here that when we select it, we can choose between different shape profiles. So here my cylindrical connector, I'm going to switch over to my smart support pin, and when I do so, you can actually notice that it changed. The shape of that support pin changed according to the height of contour or according to this equator line. And so that minimizes the footprint that I'm creating in terms of an undercut and allows me to kind of get into those sensitive areas without essentially sacrificing the integrity of my margin. So I would be a whole lot happier milling something like this out rather than leaving a round support pin on the back there. One other thing I can do with the support pin on the facial of this bridge is make it to where that pin is cuttable. So I can make it to where it's completely cuttable, like a green support pin there, and you can see that the graphic shows that that support pin will be completely removed. It'll actually finish it down to the surface of the STL. Or I can make it semi-cuttable, which will simply make it easier to cut this part out of the disk, and generally speaking, that reduces your support pin down by half of the diameter. Now, we do have other types of support pins that we can use in other materials other than the cylindrical and the smart support pin, like for example, the rectangular support pin. But we typically advise using those in materials like PMMA or titanium, metals and things like that, where you're gonna reap the better benefit of having a flat support pin in those materials. All right, once we have our support pin placement as we prefer, then the last step that I'm gonna do is just simply make sure that I have the clearances needed to reach the undercuts in my parts. In this particular case, I'm worried about this because it's a facial cutback, and you can see we have really steep angles on these cutbacks. Now, what I can't see from this side, maybe I can see from the bottom, which is good, but I do wanna create a little bit more clearance for that tool to be able to get inside of that area and work. So I'm going to go from a 3.3 millimeter part border, which is the distance from the crown to the disc. I'm going to up that to 5 millimeters. So clicking on 5, it's asking if I want to re-nest the object. I'm going to say no, so it stays right where it's at. And you can see that the part border was increased around that part. Now, to compensate for that, because these support pins are thin, I'm going to probably want to select both of those using Control and click, and then go in and increase my support pin diameter at the material, maybe 3 millimeters up to 3.5, maybe a little bit larger if I decide to go more than 5 millimeters extension, but that's a good starting point. And as you can see, I have much more clearance now for that tool to be able to get into this part. Now, if the clearance was only required on one particular side, I may decide to use my paintbrush tool to go in there. But in this particular example, because we have 3 sides of the restoration, it just makes sense to open up the offset all around the crown. So now that I have my crown more or less the way I want it, I know my bridge is more or less the way I want it, the last piece to take into consideration is overlapping your part borders, because it's going to allow you to save space in the disc. But you want to be careful not to get too aggressive or to get too close to adjacent parts, because if you do, MillBox will indicate that there's an issue there. And you also want to make sure that your support pins are actually connected to material. So you can see that this one is actually slightly disengaged here, and I definitely want to make sure that I either correct that or just move it further away. So the reason it's red here is you can see the offset itself is now overlapping with the adjacent bridge. And that's the reason why it doesn't see that it has enough clearance for that roughing tool to get in between those parts. And so in moving those slightly further apart, making sure that our support pins are in the correct location, it's going to ensure that I have a good successful mill and that I've saved as much space as possible in this particular example. So very last step to do is just take one last look at these parts, make sure that everything is in good position. I advise people to rotate their view constantly so they get a good view of where their support pins are. They make sure that they're not creating additional undercuts here, and just kind of move things around to minimize the amount of work that you're going to have to do when these parts come off the machine. So at this point, I'm ready to proceed to the calculation step. So what I'm going to go ahead and do is click on Start Mill. And I have 2 options here. On some machines, depending on your machine's capability, we can actually stream it over to the machine and the machine can start milling within seconds, which is a pretty great feature if you're in a high production facility. However, in this particular example, we're going to save our CNC file for later. We also have the option for prioritizing milling order in case you have a rush case. We're not going to cover that today in this video, but definitely be sure to check that feature out as it can help save time if you have to prioritize your cases. What we're going to go ahead and do is save our toolpath, and when we click on this, we're going to be presented with a screen that gives us choices. And this is one of MillBox's strong suits, the ability to change your strategy options on the fly according to the job that you have at hand. So here we can see that we've imported both a single unit crown as well as a full contour bridge into the case. So these choices are split up amongst restoration types. And what I can essentially do is, I know that I have undercuts on our crown, so I can say, okay, I want to come in and I want to mill those undercuts out using my 3+2 or using all 5 axes on my machine, and I want it to hit it from both the occlusal and the cavity side. And if I want to know what tools it's going to be using for that, we simply look over here to the right. We can see all of our relevant information here about our tool, including the diameter, the length of the tool. Length is very important because the reach of your tool will determine how deep that tool can go during milling. So a good example of that, we're talking crown and bridge now, but a good example where you want to pay attention to your tool length would be on hybrid cases or screw tang cases where you have a screw channel and that tool needs to reach down inside those screw channels. So something to keep in mind, but certainly that can also come into play if you're milling in a deep disc, even just crown and bridge cases. Now, if you want to understand a little bit better what some of these operations are, and you can't necessarily make it out from just reading these choices, you can click on this little information icon over to the right, and it's actually going to give you a small description as well as a view of what that toolpath would actually look like. So it's kind of giving you an idea of what it's going to execute there. Here's another good example of an operation where we can go in and provide a very detailed toolpath where the cement space is, so we can better facilitate fit in some cases, and even an option for a 0.3 millimeter tool or a 0.6 millimeter tool to come in and redefine some of the secondary anatomy. Because our 1 millimeter and our 2 millimeters have large diameters, we can't always get the detail that we actually designed in the case. So the key is utilizing those smaller tools and stepping down to those smaller tools to be able to produce those secondary anatomy details. And we can do the same thing for the bridge. You can see here it's been turned on by default. Now, my particular bridge doesn't really have any undercuts, so I don't need to select any external undercuts for that. It would just equate into extra mill time for nothing unless I actually have undercuts on that job. So it is relevant, the choices that you make. You don't just want to go through and select all the options that are available, because you could end up with a very long mill time when in reality you're looking to get a part off the machine maybe in a faster time frame. So I say you make the more selections you make here, the longer it's going to take the machine, the more detailed your part is going to be. So if you're just getting started, you're not quite sure what that quality benchmark should be, my suggestion is try it out with all the options unselected, try it out with some options selected, and try it out with all the options selected, so you can kind of understand those differences for yourself and also understand what the different choices mean and how those impact how your machine is going to try to mill these parts out. So once you've made your choices, we're simply going to select the check mark to continue. And the very last step that I have here, or the very last informational piece that's going to pop up, is the CAM software telling me what tools need to go in what slots. So typically your machine's going to have tool slots numbered through, let's say 1 through 30, or depending on your machine, whatever the max number of those tools are. Tool slot number 1 is going to be T1 or tool 1. And so when that image pops up to kind of let us know, hey, this is where those tools need to go, that's your kind of signifier that I need to make sure that those are the actual tools loaded in the machine, and they need to be loaded in the correct position, because the machine's not going to know which tool is which. It's just going to know that it needs to go to that particular tool slot to pick up the tool it needs for the job. And so here's our final tool table reminder that we get. We can see that the 2.5 millimeter ball tool needs to be loaded in slot 2. The 1 millimeter short tool needs to be loaded in slot number 3. I have a 0.6, in this case the 6 is represented by an X, could be a 0.8 depending on your machine's configuration. That would be in slot 4, and then in slot 7 would be our 0.3 millimeter ball nose tool, that it's going to be utilizing both tools 4 and 7 for that secondary anatomy. So pretty cool stuff that kind of lets us know what we can expect, what tools are going to be utilized for this job. And from this point, I just hit the check box and wait for my calculation to finish. So once my calculation's finished, I'm going to end up with a CNC file that I can then drag and drop over to the machine. MillBox will pop up a window and indicate where that file has been saved. If you do have trouble locating that file, never fear, there is a shortcut under Tools, and we can simply click on CNC output files in order to find those output. And that's it. If you follow these steps, then you should be able to get through the crown and bridge workflow and maximize your success in doing so. If you found these videos helpful, definitely be sure to check out our other videos in the MillBox Expert series and check out our help pages at help.simsystem.com. Thanks for watching.